Welcome to General Mathematics, and in this video we're going to continue our discussion on the application of exponential decay, of exponential functions in terms of decay. So here we're going to look into the decay of radioactive substance. So the decay of a radioactive substance is by half-life. So when we say half-life, so it is the amount of the time it takes for half of the substance to decay. So for the original amount of a material, for example, we have 8 grams. So, ano yung kalahati ng 8 grams? So, kapag ang kalahati ng 8 grams is 4, di ba? So, ang kalahati ng 8 is 4. So, therefore, after some time, this substance will reach or bababa siya into 4 grams. So how long will it take for this material to decay half of itself? So that time, the value of that time where half of this material will decay is called the half-life. So here, instead of looking for the value of the time, instead of looking for the value of the half-life, we're going to look for the value after the half-life, after the defined half-life. So here, we're going to look for the future value of the radioactive substance, or maybe we can also look for the initial value of the radioactive substance. So the model, we have here the model, since we're looking and we're talking about half-life, so we're looking for the value where 50% of the original amount will be decayed. So therefore, from original value minus 50% of the original value. So we have here the following models which we can use, or the following equations which we can use to solve for the half-life. So instead of y in this one, so let's just use ito na lang. So a is equal to a of o times 1 minus 0.5 raised to t divided by t, or dito pwede rin a is equal to a of o times 1 half raised to t divided by t, or dito pwede rin na a is equal to a of o times e raised to negative kt. So ayan, so ito yung gagamitin natin. So ito na lang gagamitin natin. Ayan, kasi 1 minus 0.5 is just 1 half, or just 0.5. If you don't like to use the fraction form, you can just write here 0.5 raised to t over t. So ito yung gagamitin natin. So depende sa given sa ating problem. So we're going to use this. So this is the initial and this is the future amount. Future amount. Intindihin nyo na lang yung sulat ko yan. So, and again, this is the defined time, and this is the time interval, and this is the growth factor. This is our relative growth factor relative to the defined time, and this is our natural base b. So let us have some examples to understand how the decay by half-life works. So example number 10 for the decay by half-life. Suppose that the half-life of a radioactive material is 20 days and there are 10 grams initially. Determine the amount of substance remaining after 75 days. So meaning, itong 20 days, after 20 days, the amount of this, if we have an initial tawag dito, for example, if we have an initial value of 10 grams, after 20 days, this 10 grams will be equal to 5 grams. But here, we're talking about 75 days. So, after 75 days, ilan na lang ba ang matitira? So, let us use our equation. So, ang gamitin natin dito is A is equal to A sub O times 1 1/2. Wait lang. Palitan natin to. 1/2 raised to t divided by the defined unit of time. So, a is equal to, ano yung value? Wait lang. So, ano pala natin? Identify natin yung given. So, identify the given. So, a is unknown. The future value is unknown. The initial value is equal to 10 grams. 10 grams. And then, we know the rate, which is 0.5. And then, we have here the defined unit of time is equal to 20 days. And our time interval is equal to 75 days. Yeah. So, let us now substitute this equation. So, A is equal to 10 grams times 1/2 raised to 75 divided by 20. So, since pareho naman silang in terms of days, so there's no need to convert this one into this one. Kasi pareho naman silang days. So, 10 times 1/2. 75 divided by 20 is 3.75. So, 1/2 raised to 3.75. So, 10 times 0.07432544469. 44469. Mahaba. Okay. So, 10 times this value is equal to, tawag dito, 0. I-round off na lang natin siya into 0.74 grams. Yan. So, 0.07432544469 times 10 is equal to 0.74 grams. So, we can also write this in terms of function notation. So, ang sabi natin that our independent variable is our time interval. So, therefore, we can write this in terms of this one. So, a of 75. So, the function of 75 is this one. So, to produce this value of 0.74 grams. So, to write the final answer, you need to conclude. So, as a statement, because this is a problem solving. So, therefore, to conclude, we can say that only 7.74 grams of the substance of the radioactive substance is left correct nyo lang yung grammar nyo. Okay, so after 75 days. 75 days. So, yeah. So, this is the amount of the substance after 75 days. So, if this radioactive material decays, radioactive materials decays half of itself every 20 days. So, this is your final answer. So, conclude your statement. So, another example. So, example number 11. Meron ba tayo next? Okay. Yan. So, example number 11. A certain radioactive material decays half of itself. Yan. Decays half of itself every day. So, initially, there are 20 grams. How much of the substance will remain after 8 days? So, again, ang gamitin natin na equation is A is equal to A sub O times 1 plus 1/2 na pala to. And subtraction pala to. Okay, so, times 1/2 raised to t times t. So, our future amount is unknown. So, our initial value is equal to 20 grams. We have, so, ang ano natin, ang defined unit of time is every day. So, therefore, t is equal to 1 day. Yan, 1 day. And then, ang defined natin na interval of time is 8 days. So, 8 days. So, since, 1 day, okay. Ay, tama. So, 1 day, so 8 days. So, there's no need to convert. So, therefore, we can use now these values, this given, to solve for the future value. So, A is equal to, A sub O is equal to 20 grams, and then times 1/2 raised to 8 divided by 1. So, 20 times 1/2 raised to 8 is equal to 20 times 1 over 256. So 20 times 1 over 256. So A sub 8 is equal to 0.08 grams. So after 8 days, therefore, after 8 days, only about 0.08 grams of the substance will remain. So that is our answer for this problem. Ayan. So ito yung meaning ng ating answer. So let us answer our example number 12. Meron ba tayo? Okay, wala na. So example number 12. So, a radioactive element decays such that after T days, the number of milligrams present is given by N is equal to 500 E raised to negative 0.000124 T. Letter A, how many milligrams are initially present? And letter B, how many milligrams are present after 15 days? So, sagutan muna natin si letter A. So, select 15,000 days. So, letter A, sabi natin that the equation is N is equal to 500 E raised to negative 0.000124 T. So, this is in the form of A is equal to A sub O times E raised to negative KT. So, we know that A sub O is our initial value. So, therefore, we can say that the initial value, since the equation states that N is equal to 500 E, 500 times E raised to negative 0.000124 T, then the initial value A sub O is equal to 500. So, i-sentence form nyo na lang. So, para hindi ko na dito isulat. So, the sentence form na lang yung reasoning nito. So, since from the equation, it was given that N is equal to 500 times E raised to negative 0.000124 T, and the pattern here is based from the model A is equal to A sub O times E raised to negative KT, and we know that A sub O represents the initial value. Then 500 here, since 500 is equal to A sub O, then the initial value, the initial value, amount of the substance is equal to 500, and this is milligrams. So, yan. So, lagay nyo yung unit. So, let us now answer our problem letter B. So, for letter B, isulat natin yung equation. N is equal to 500 E raised to negative 0.000124 T. So, this is the model for this problem. So, how many milligrams are present after 15 days? So, since we already have a model, ang kailangan na lang natin is to evaluate this function at T equals 15 days. So, N of T is equal to 500 times E raised to negative 0.000124 T. So, since t is equal to 15,000. Yan. So, 500 e raised to negative 0.000124 times 15,000, yan, is equal to 500 e. So, negative 0.000124 times 15,000 is equal to negative 1.86. So, dito na tayo. Ay. So, equals. So, 500 times e raised to negative 1.86 is equal to, wait lang, negative 1.86. Okay, so nagkamali lang ako ng enter sa calculator. So, yan. So, e raised to negative 1.86 is equal to 1.0.15567 yan. So, times 500. So, n when t is equal to 15,000 is equal to 77.83631,518 or n of 15,000 is equal to, approximate na lang natin siya into 2 decimal places para pare-pareho tayo ng sagot. So, wala ko dito. So, ano na lang natin, round off natin siya into 2 decimal places since we're talking about, mass of, tawag dito, mass of substance. So, to the nearest 2 decimal places or the nearest hundreds. So, itong value na to, we have here, this would be approximately equal to 77.84 grams. Yan. So, therefore, after 15,000 days, the amount of the substance left is approximately equal to 77.84 grams. So, i-sentence form nyo na lang yung final answer niyo. And this would end our discussion on the different applications of real life applications of exponential functions. So, in our next video, we're going to look into the relation, how logarithmic function is related to exponential function by looking at a different real life applications of logarithmic function. So, we're going to look on we're going to determine, so dito diba sa radioactive decay, dito sa decay by half-life, we determine the amount of substance before and after. So, in our next video, we're going to examine word problems where the given or the values were given, or the rates or the growth factors and the initial or the future value, and the missing is the value of our independent variable, so yung exponent natin. So, we're going to look into the value of t. So, if t is missing, how do we find t? So, that will be discussed in our next series of videos. So see you in our next discussion.